So let us now go to the second problem of this tutorial. As you can see, the pressure is now 26 MPa and the temperature is 200 degrees centigrade. Alright, so the pressure and temperatures are given, and one can directly see from this that pressure is more than P critical, or the critical pressure, which is 22 MPa. So 26 MPa is more than 22 MPa, and therefore we know that the pressure is beyond the critical pressure, and also we can see from here the temperature is less than T critical. The T critical value is 373 degrees centigrade. Can you understand from these two parameters where will this point be in this zone? Let us solve this problem, and one can actually see a direct answer to this problem, but we can solve it using the steam table also. So question number 2, P is equal to 26 MPa and T is equal to 200 degree centigrade. Alright, this is the problem. As I said that we know that P is greater than P critical, because P critical is equal to around 22 MPa for water, which we all know now. Now if I just draw the diagram on a PT diagram, this is my LV line, let us say from TP to CP, and corresponding to this parameter CP point, we have got this as 373 degrees centigrade approximately, and this is 22 MPa. Because P is more than P critical and T 200 degrees centigrade is less than T critical. So I am on this side of the temperature, alright, and my pressure is above this. Let us say this is 26 MPa. So 26 MPa and less than 373 degrees centigrade. So I am sure my point lies somewhere here, because 273, let us say somewhere over here, 200 is somewhere here as compared to 373. From here, therefore I can easily straight away say that this is my subcooled region or compressed liquid region. So one can get directly a feel from knowing that it is P is more than P critical and T is less than T critical. I know that it is in subcooled region. Alright, so directly answer qualitatively, one can get this answer directly. Now let us use steam table, and let us go to steam table number 1, find out for T is equal to 200 degrees centigrade what is P sat T. Alright, so let us go to steam table now, table number 1, and find out at T is equal to 200 degrees centigrade what is the P sat T. So find out, locate from table 2 and see the value. So this is table number 1, and you can see from here that T is equal to 200 degrees centigrade, the P sat T value is 1.5549 MPa. Just note down this value and come back to the calculations again. So I can write the P sat T value from here and compare this P value with the P sat value. So our P is 26 MPa and the P sat T is 1.55 MPa. So P sat T is equal to 1.554 MPa, and therefore I say my P is greater than P sat T. So if you remember, this is P sat T, let us say for this 200 degrees centigrade, corresponding to this is P sat T, and therefore because P is more than P sat T, we are in this. Straight away the answer now comes that we are in subcooled or compressed liquid zone. That is the answer. Let us come to the answer sheet. So I will write here For the case number 2, serial number 2, P is equal to 26 MPa, T is equal to 200 degree centigrade. We are in subcooled or compressed liquid zone. Let us now look at the third problem, which is P is equal to 2 bar and S is equal to 6.2 kilojoule per kg Kelvin. So, you can understand that now I do not have P and T values. What I have been given to me is pressure and entropy, which is a little tricky problem now. So, P is equal to 2 bar or 0.2 MPa and S is equal to 6.2 kilojoule per kg Kelvin. Let us now see this problem and let us solve this problem. So, question number 3 is P is equal to 2 bar, S is equal to 6.2 kilojoule per kg Kelvin. Now, we do not have P and T as normally what we would like to have, this is not there. What we have is S. So, what I would do, I will go to P is equal to 2 bar and find out the corresponding entropy value, which is in terms of SF and SG, alright, saturated liquid line, saturated vapor line, and then we will compare given S value with SF and SG. So, let us go to P is equal to 2 bar and try to get the value of SF and SG. So, P is equal to 2 bar means again I would go to table number 2 because pressure is a base in this case. Can we go to table number 2? So, this is table number 2 where the base is pressure, and now let us go to 2 bar or 0.2 MPa. So, you can see here now we are at 0.2 MPa at this point, and now I would like to see the entropy here. This is volume, energy, enthalpy and entropy. Under entropy what you can see is you got SF and SG, saturation liquid line, saturated vapor line. So, let us try to get this SF and SG values because this is the only values that are available to us from table number 2. So, at 0.2 MPa this is my SF 1.5302 and my SG is 7.1269. Let us write down these two values as SF and SG, and then we can compare this value with the S that has been given in the problem. So, let us come back to the calculations now and let us try to compare the S value with this SF and SG. So, what we have found, SF for P is equal to 0.2 MPa, SF equal to 1.5302 kilojoule per kg Kelvin and SG is 7.1269 kilojoule per kg Kelvin. Given S value is 6.2 kilojoule per kg Kelvin. What does it mean? It means that SF is less than S and S is less than SG. This is a very important understanding that we have got with the values of SF and SG. Alright, have your attention here. We have got SF here and we have got SG here, and given S lies between this SF and SG. Our S value is 6.2, our SG value is 7.12 and our SF value is 1.53, and we say therefore 1.53 is less than 6.2 is less than 7.12. That means this is a two phase region. This will lie on saturated liquid vapor line and this will lie inside the dome. That means it is a two phase region. So, answer to this problem is it will lie on a LV line and it is a two phase region that we are going to be referring to get these properties from. Coming back, therefore, I can conclude that we are on saturation line, or we can say that we are in wet vapor region. So, the third problem what we solved is P is equal to 2 bar, S is equal to 0.62 kilojoule per kg Kelvin. This is on LV saturation line or wet steam, whatever you want to write. You can write even two phase region where liquid and vapor stay together, but normally the region could be on a saturation line and wet steam or two phase, all are correct.